I want to look at a few applications of this charging by conduction, charging by induction stuff. The first thing you see is what we call an electrostatic precipitator, which is basically an air filter. You have air filters in your house. Everybody does. Some people have ones that they plug into the wall that sucks air through it and filters out little pollutants or little dust particles. Everybody has a filter in their furnace. You guys know that in most of the rooms in your house have what's called a cold air vent. There's the warm air vent on the floor, but then there's the cold air vent that's on the bottom of the wall. That's a pressure thing, right? If we pump all this warm air into a room and we don't suck any cool air out of the room, then it messes with the pressure of the house. So we have this cold air vent, sucks cold air in, goes down through the ducts into the furnace, and then that cold air gets warmed up in the furnace and gets pumped back up into the rest of the house through the warm air vents. But as it does that, it goes through a filter in your furnace that sucks dust particles or filters dust particles out of the air. So it's kills two birds with one stone, right? It's a good way to get air into the furnace, because the furnace, of course, needs air in order to pump it up and warm up the house. And it's a good way to filter out pollutants or dust particles in the air. If you've seen your furnace, you might know that there's this rectangular, usually it's about 2 feet wide. Okay? You push it in, or about 2/3 of a meter wide. You put it in your furnace, you pull it out, and you can see that it's basically this fibrous material that literally traps dust particles and dirt particles. Change it every 3 months. And when you pull it out after 3 months, it's usually pretty dirty, which kind of gives you an idea as to the air that's going through there in the first place and what you're breathing, okay, if you don't have that filter in there. It works decent, but if the particles are smaller than the distance between the fibers, then they're going to make it through. Right? You got small dust particles or small pollutants, they're going to make it through. What would be better is if we had an electrostatic system. An electrostatic system can filter out essentially any size particle. Here's how it works. This is an electrostatic precipitator where we have, first of all, a power supply or a battery. You can see that this is a symbol for a battery. One long line, one short line. The negative side of the battery or the power supply is always the short one, and that's labeled here. Not always labeled, but the negative side will always be the short side. That causes electrons to leave the negative end, get pushed around clockwise here. Go this way, and then go back this way into the positive side of the power supply. Those negatives leaving that and going clockwise cause these blue rods to become negatively charged. Right? Negatives leaving the battery collect on these blue rods. Now, negatives are coming back from the red to the positive side of the power supply. That makes these plates here, these red plates, become positively charged. Now, over here on the left-hand side, you can see this air being blown through this precipitator, being pushed through this precipitator. And inside that air, you know that there's dust particles and pollutants of different types. And generally, those dust particles and pollutants are neutral. They're not charged. But when those pollutants and dust particles get blown through those negatively charged rods, when they touch those negatively charged rods, when neutral particles touch negatively charged rods, what happens? Those neutral particles will become negative, right? That's called charging by induction or conduction. What is it? It's called charging by conduction. When neutral touches negative, then electrons transfer from the negative to the neutral and make them both negative. Now, it's probably not going to balance out here. They're not equal size. They're not equal shape. The dust particles are not identical to these rods, but they're both going to become negative. So now I've got these dust particles that were neutral and are now negative, continuing to be blown through these plates that are positive. What happens to the negative dust particles now? As they get blown through these positive plates, They get attracted to the plates. They stick to the plates. And what goes through the other side? The air. The air minus the dust particles that were electrostatically charged on purpose so that we could have an easier job filtering them out with these positively charged plates. Now, it's not perfect. It doesn't mean you're going to get perfectly pure air coming out the other side, but you're not limited by the spacing of the fibers in your filter if this is the case, right? Okay, and with a traditional mechanical filter, if the spaces between the fibers are too big, then the particles are just going to go straight through. And that's not going to happen here. So there's one application. Here's another one. I decide I want to paint the fence in my backyard. This is my backyard, by the way. After I win 649 tonight, this is going to be my backyard. I get tired one day of looking out the window, my back window, looking at my backyard. Listen, if you had to look at this backyard every day, you'd get tired of looking at it too, right? Okay, the black wrought iron fence around my big pool beside the ocean. Maybe I want to change the color of my fence. So this is what I do. Somebody has this bright idea where, well, you just get some paint in a can and a brush and paint it that way. I don't want to do that. Okay, I don't want to do that. That takes too long. I want to spray paint at it. But the problem if I spray paint at it is that A, I'm going to lose a lot of paint. I'm going to waste a lot of paint. It's going to cost a lot more money. And B, some of the overspray is going to go on my nice deck around the pool and maybe even in the water itself, and I definitely don't want that. So what I do is use this electrostatic painting system. Okay? This electrostatic painting system involves taking this nozzle that you see has this tube which would go into a bucket of paint basically. And in this nozzle, we have a rod that's either charged positive or negative. We'll make it negative, although it doesn't really matter. When the paint particles, which, by the way, in this context, it isn't usually really paint. It's usually really like a powder, okay, that ends up getting baked on. But we'll call it paint. Okay, this paint goes past this negatively charged rod. It becomes negative, right? Neutral paint touches negative. Neutral paint becomes negative. Negative and neutral become negative and negative. They want to balance out. They probably don't balance, but they try. They both become negative. So now you get this paint that's negatively charged going towards this fence that is grounded. It's not like we have to ground it. It's in the ground. It's already grounded, right? So now these negatively charged paint particles get attracted to this neutral fence, and they stick to it. And then they dry, and then you've got a painted fence. Well, what's the advantage of that? Well, if you look at it from above here, this is our fence post right here, looking at it from above. All these paint particles that are going this way, well, they would have struck the fence anyways, right? But these paint particles that were going up here would have blown right past and then probably got on the deck surrounding the pool or got into the water or whatever. But now what happens to them? Because they're negatively charged, and this is a neutral conductor that's grounded, they get attracted to it. Not only does it provide better coverage of paint on the fence posts, but you end up not losing the paint. So this overspray that was missing the fence posts ends up coming around and going on to the fence post on the side or on the back of the fence post. Make sense? Okay, you can't really do that with a wooden fence, right? Remember years ago I was painting my fence at my house. It's wood. Okay? Well, I wanted to spray it. I knew I couldn't use something like this, not that I have a system like this, but even if I did, it wouldn't work because it's a wooden fence. Okay? I need that metal fence. I need that conducting fence that I can ground. And of course, I ended up not using a spray paint because I didn't want to spray paint all over the neighbors, all over the side of the neighbor's house, right? Make sense? Now this is called, device you see up here, not on the sheet that I handed out yesterday, it's called an electroscope. Don't try to draw what you see up on the board there. I'll simplify that, okay, in just a second here. An electroscope is quite simply a device that detects charge. That's it. It detects charge. It doesn't tell us how much charge we have. It doesn't tell us even what type of charge we have, positive or negative. It just tells us that we either have charge or not. Now, an electroscope in its simplest form looks like this. We'll have a steel or some kind of metal rod, copper, something like that conducts electricity. There's going to be a ball on the top of it, and then there's going to be two, usually it's really thin foil leaves on the bottom of it. Sometimes it's these two little, we call them pith balls, that hang from really thin strings off the bottom of it. It doesn't really matter. Two light things that can gain a charge. And now usually we have some kind of container around it to keep the air from blowing on it or whatever. Now, how does this detect charge? Let's say I bring a positively charged object nearby. This electroscope was neutral. Equal number of positives and negatives. When I bring that positively charged rod or object nearby, what happens? What happens to the protons in this electroscope? Nothing. Nothing. Nothing ever happens to the protons. That's the answer to that question, always. Nothing. What happens to the electrons? Push down? Somebody say they get pushed down? But they don't get pushed down. This is a positively charged object doing the charging. What happens to them? They get pulled up, right? They get attracted to this. So what we're going to find, and remember, it's not all of them. I'm just going to draw it as if all of them do, right? Just to simplify it. We get a bunch of these electrons up in the ball of the electroscope. So the ball of the electroscope becomes negative. The leaves of the electroscope become positive. What happens to them now as a result of both leaves being positive? Yeah? They push each other apart. They repel. Positive repels positive, and they push each other apart. So it's going to look something like this. That tells us there's charge present. Doesn't tell us how much we have. Doesn't tell us what type we have, but we do know that there's charge present. Now, what would happen if I attached a ground wire to this, anywhere? Or touched it with something that could serve as a ground wire? Now this positive object wants to suck negatives up from the earth. Now you get a whole bunch of negatives, a whole bunch more negatives in here. And at some point, the ball of this electroscope can't hold all the negatives, so now a bunch of them get pushed down into here. The leaves were positive, and they repelled as a result of that. Now they're negative, so they will still repel. And they'll still stay spread apart. That make sense? What would happen if I remove that ground wire? What would happen if now I took off that ground wire, cut the ground wire? Now the leaves of the electroscope would stay spread apart on their own because there's no way for the electrons to go back down into the ground. Now we say permanent. It doesn't really mean permanent because eventually charge is going to discharge through the air, but we say it would be permanent. If you come up and grounded it again, though, the leaves would come apart. If you took the charging object away, took this thing away, came up and grounded it or even touched it, you would drain the charge and the leaves would go back down to being straight down because of gravity. What happens if I bring a negative object nearby? Whoops, way too big. We're going to bring a negative object nearby. What happens? Well, this time the positives are still there, but the negatives are going to get pushed down into the leaves. Leaves are going to spread apart, whether it's negative or positive that I'm bringing nearby, right? Ground it. What happens? Well, now the electrons, they don't get pushed down into the leaves anymore. Now the electrons are going to get pushed down into the ground. And that's going to leave the leaves, positive. They're still going to spread apart. Cut the ground wire, they'll stay spread apart because the charges that went down into the ground have no way of coming back.